All right, let's talk briefly about chemical and physical properties. So first let's define a physical property. So a physical property is a property of matter, and matter is what stuff is made of. So it's a property of a substance or matter that when you measure or observe that property, that once you're done measuring or observing that property, the substance is still the same substance that it was before, so it doesn't change in chemical composition. So let me give you an example. So here I just have a piece of yellow paper, and you could describe it in a number of ways. You could say that it's yellow, so I'm actually going to write right on it. It's yellow. It's square in shape. It smells kind of musty when you smell it. I smelled it. It smells musty. It smells like paper. Let's see, it's smooth. It's a solid. I can actually, so all of these are just observations that I'm making about this paper. It's flat. It has a particular, well, let's talk about things we can measure. So I can take a ruler and I can actually measure it, and it is about 7.5 centimeters in, so 7.5 centimeters all the way around. So we'll say 7.5 centimeters in length. I could actually weigh it if I wanted to. So I've got a scale right here, and I don't know if you can actually read the scale at all. I'll try to get it to 0 here. But I can put this paper on the scale and I can weigh it, and it weighs about 0.43 grams. So I can write down that it has a mass of 0.43 grams. And so there's all these different things I can say about this piece of paper. I could probably figure out its volume if I wanted to try to figure out its thickness, which would actually be something I couldn't do with this ruler right here, because you know, if I tried to measure how thick that is, it'd be really hard to do with this ruler. But regardless of that, I've basically listed just a whole bunch of physical properties about this substance, and notice that when I made these observations, that it was yellow and it's square and all of this, that when I'm done making these observations, I still have paper. So a physical property is, you know, something that once you've made the observation, it's a characteristic that once you've made the observation, or once you have measured whatever it is you're measuring, when you are done, you still have the same chemical substance that you had before. This is still paper. So let's kind of list some examples of chemical properties. So we'll keep our little paper right there. So yellow, that's color, and we said what shape it was and how it smelled, and that it had a certain texture to it, and what state of matter it was in. So that's when we said it was a solid. We measured its dimensions, or some of its dimensions, length, width, height, that kind of thing. We measured its mass. We didn't measure its volume, but we could if we wanted to get all crafty with it. So these are all examples of physical properties. I want to talk a little bit specifically about density. So by no means am I going to, by the way, list every physical property there is. I just want you to remember that a physical property is a property that once you have made the measurement, the substance is still the same substance. So let's talk density. So I don't know if you remember what density is, or if you have ever talked about density somewhere else, but density specifically is a measurement of something's mass in grams divided by its volume in either milliliters or centimeters cubed. An easy way to remember how to calculate density is density equals, and then draw a heart, and then draw a line through that heart. And you'll notice the top part of the heart becomes an M for mass, and the bottom part becomes a V for volume. So you're dividing mass by volume. Remember the units on density, grams per milliliter, because you're dividing grams, mass, by volume in milliliters. So notice I kept density under physical properties. So we could talk about this piece of paper again. So even though, oh, and by the way, the fact that I wrote on it is a physical property, that ink sticks to it. Notice that it's still paper, even though I wrote on it, it's still paper, so it didn't turn into something new. But back to the density. So I'm gonna tear it in half. So that tearing it in half didn't change it to a new substance. It's still paper. So the fact that it's tearable, that I can tear it in half, that is a physical property. But also notice that before I could have measured its volume and its mass and calculated its density. But now that I cut it in half, does the density change? Well, you might say yes, right? Because I just tore it in half. I now have half the paper that I had before. But so its mass certainly went down, right? Because I just took half of it away. But also, didn't its volume also go down because I just took half of it away? So its density should remain the same. So the point is that density is definitely a physical property because, again, let's face it, this is still paper. Just because I tore it in half and I removed part of it doesn't make this not paper. It's still paper. Okay, so that's examples of physical properties. And again, there's tons more physical properties, but we're gonna just deal with those we're just gonna give you some examples. So let's talk about some more physical properties. Or actually, let's talk more about this paper. So here's the paper I just had. I'm gonna do this to the paper. So what am I doing to the paper? I'm burning the paper. And let me get this little thing, and I will catch the stuff that I just made. So what I just did here is I burned the paper, I lit it on fire, and I'm not talking about this stuff anymore, I'm talking about this right there. So it's sort of shiny, I'm sorry about that, I'm trying to move it so you can see it a little better. There you go. This that I just made, these ashes, are no longer the same substance that I had here. This is paper, this is ash. So I just underwent, or I just measured a chemical property of paper. I measured its flammability. So how do I know that flammability is a chemical and not a physical property? Well, let's talk about what a chemical property is. Sorry about the mess. So a chemical property is a property that, when measured or observed, does result in a change in the chemical composition of a substance. And you can tell that the chemical composition of this paper changed when I burned it because you can see that it now has different physical properties. It went from being yellow and smooth and having certain physical properties to now being an ash. It's kind of powdery. I certainly can't write on that. It's a different color. It's gray instead of yellow now. So I just measured a chemical property of that paper. So examples of chemical properties: flammability. Let's talk about other chemical properties. So we'll do something really simple. I'm going to put a piece of paper down or something underneath this just so that if it makes a mess, it's not going to mess up my notes. So here's a beaker of vinegar, and then I have a beaker right here of baking soda. Now, we could, of course, talk about the physical properties of both of these things. So I could talk about the volume. You can't see it, but there's about 150 milliliters of the vinegar, and there's about 10 milliliters of the baking soda. So those are both physical properties because making that observation didn't change this or this. We talk about their colors and their textures, the state of matter. This is a liquid, this is a solid. But when we combine the two, hopefully you'll see that something happens. It fizzes and it bubbles. And that fizzing and bubbling means that a gas was being produced that wasn't there before. So I've actually observed a chemical property of both vinegar and baking soda. So that chemical property is reactivity with another, so reactivity with another chemical. Baking soda has the chemical property of being reactive with vinegar. So it reacts with another chemical. So let's kind of talk about that a little bit more. Let's do some more examples. So again, a physical property is a property that, when observed or measured, does not result in a change in chemical substance. So you still have the same substance you started with. And then the chemical property, a chemical property is when you observe that particular property or you measure that particular property, and when you're done, you have a new substance. It's created something new. So I have here a beaker of just water, and this is a stir rod. And again, we could describe some physical properties of this water. And I've got sugar. So here's some sugar. And I am going to combine the two. So I'm going to put the sugar in the water and I'm going to stir it around. So it's going to take a second. I'll stir, stir, stir. And while I'm doing that, we can kind of, sing a little song or something. It's pretty exciting. I know you're really thrilled by watching me stir this water. Okay. So as I stir, I hope that you notice that it looks like, the sugar just went away. It looks like that what I ended up with was just water. So I'm going to put a little black background on this so you can see that it looks completely transparent. There's nothing in the bottom. So it looks like the sugar just disappeared. So where the heck did it go? But the question that I'm going to ask you, because you're, an intelligent person and you've seen this happen before, is what just happened to the sugar? And you're going to tell me that the sugar dissolved into the water, which are absolutely true. That is absolutely true. So did the sugar disappear? Did the sugar become something new when I put it in the water? And hopefully your answer is no. It's still sugar. What I made when I mixed sugar and water is sugar water. It's a mixture of sugar and water. So the fact that sugar dissolves in water, is that a chemical or a physical property? It's solubility in water. Well, did I make a new substance? Did I change the sugar's chemical composition? I didn't. So solubility is also a physical property, because when I dissolved that sugar in the water, what I end up with is just a mixture of sugar and water. I didn't make a new chemical composition. I didn't make a new substance. I just made sugar water. And what should really make you realize that this is a physical property is that I could easily separate those substances from one another. If I wanted to, I could just evaporate off the water and I would be left with the sugar because it's been there all along. It didn't change chemically. So just remember that solubility is also a physical property. So that's a physical and a chemical property. That's the difference. Again, physical properties, once you're done observing or measuring, if the substance is still the same substance chemically, then you've got yourself a physical property. And a chemical property, if you have